Okay, so here's the examples that you were supposed to do on your own. If you haven't done them yet, I must stress that you should pause the video and do them right now to get your practice in. So this is 4 squared to the 7th power. And so that would be 4 to the 2 times 7, following our rule. A to the n times... let's try it again. A to the n to the mth power is a to the n times m, which means this is 4 to the 14th power. This one here is negative 2 to the 4 times 5, which means that this is negative 2 to the 20th power. This one here is n cubed to the 6th power, or n to the 3 times 6, which is n to the 18th power. And then finally, this is m plus 1 to the 5th power, being taken to the 4th power, so it's m plus 1 to the 5 times 4, which makes it m plus 1 to the 20th power. Again, if you have questions in these, feel free to leave them in the comments, or please find and contact me before you move on to the next section here, because we're going to move on to our last property of the lesson, which is called the power of a product. And the power of a product looks like this. What if we have two numbers being taken to the 3rd power? Well, again, what we're really doing here is a times b times a times b times a times b. And notice that this is a times b times a times b times a times b times a times b. And when we multiply, it doesn't matter the order in which we multiply things. So really, this is a times a times a times b times b times b, or a cubed times b cubed. Notice that what we did here is that we said everything in the parentheses, every term, is being taken to the 3rd power. So this is a to the 1 times b to the 1. So we have a to the 1 times 3 times b to the 1 times 3. In other words, every power inside those parentheses was taken to the 3rd power. Or in general, a, b to the a to the n, b to the n to the mth power makes a to the n times m, b to the n times m, right? Everything's being multiplied. Let's do some examples. This is 24 times 13 to the 8th power. In other words, using our product of power rules, this is, again, a b to the m is a m b m. This is 24 to the 8th times 13 to the 8th. And again, we could figure this out. This is a very large number, 24 to the 8th power times 13 to the 8th power. Exponent notation is sufficient for this. But notice that the 8th power went to both of these through multiplication. Let's look at b, 9xy to the 2nd power. Again, everything in here is going to be taken to the 2nd power. This is 9 to the 1 times 2. There's a multiplication there. Times x to the 1 times 2 times y to the 1 times 2. Or 9 squared times x squared times y squared. Which, like I said, in exponent notation, this is proficient. 9 squared we can actually do because it's a fairly easy number. So I'm just going to write it down. So it's 81 x squared y squared. Again, notice that the power of products means that whenever we're multiplying in here, everything is being taken to the 2nd power. Let's do this one here. Here we have a negative 4 being taken, multiplying the z being taken to the 2nd power. So that's negative 4 to the 1 times 2, because there's a 1 here, right? And there's a 1 here, times z to the 1 times 2. So we get 16 z squared. Notice that the negative times a negative made that a positive 16. This is why your product of powers is so important. But part D shows one of the weird things that can happen. Notice that this negative is outside of the parentheses. That means we are not taking this negative and squaring it. This is negative 4 squared z squared, or negative 16z squared. This is why I was saying those parentheses are so important, because if the negative is outside of the parentheses, the negative stays there. When the negative is inside the parentheses, it's a negative times a negative, which makes it a positive, right? Notice the difference. It is very fine. Be careful, okay? All right, that concludes this video. We'll have one more with some examples that are on your Canvas lesson, so go ahead and do those right now.